Hi guys, hey, this is Mr. Straits. I had several people contact me and say they couldn't remember how to do elimination, so I thought I'd really quickly go through the notes on 3.2b again, which is the last day, Friday, which some of you kind of zoned out on me here. It was a little bit too exciting as we'd already had school canceled. So let me go ahead and go over this. Don't forget that you can pause this screen presentation at any time. I'm going to look at elimination, and my project here is to look at this, to look at the x's and the y's and decide which of those would be easiest to eliminate. Now, positive and negative, you need opposites in the two lines, so equation 1 and equation 2. I need opposites. I don't have opposites in either x's or y's as I see the colors here. But if you look at the oranges, the negative 3y and the positive y, if you took that second equation and multiplied the whole thing by 3, you would have, wow, I'm not getting a 3 there. Okay, let's try this again. My pencil's not working here. By 3, this would give me a 3x plus 3y equals 3 times 3 is 9. And then if I just slide the first equation on over, that would give me a 5x minus 3y equals negative 1. And then if I add those together, notice that the negative 3y and the positive 3y would cancel. If I add up what's left on the left side, that would give me 8x, and add up what's left on the right side, that would give me 8. Isolate x by dividing by 8, and I get x equals 1. So there I found my x value. Then if I take that x equals 1 and slide it back up into one of the equations, well, let's go back to that second equation. If I put 1 in for x, that's going to give me a 1 plus y equals 3. Well, 1 plus y equals 3. Subtract the 1, and you're going to get y is 2. Leaving me with an x of 1 and a y of 2. My ordered pair then would look like 1, 2. My check, I'm going to take that expression and put it back into the first equation. So I'll come up here, and that would be 5 times 1 minus 3 times 2, which is 6, equals negative 1. And I can't seem to get that on there. Let's try that again. So that would be 5 times 1, or 5, minus 3 times 2, or 6, should equal negative 1. There. And 5 minus 6 does equal negative 1, so that's a check, and it works. This is a good solution. Okay? That's the process of elimination, finding a way to eliminate either my x's or my y's. Now, let's slide down just a bit, and we'll look at this second one. I've got 4x plus 2y equals 9, and negative 4x plus 3y equals 16. Okay? If we just flat out added up those two equations together, look what happens to the x's. They cancel each other out. I would have 2y plus 3y, which would give me 5y, and 9 plus 16 would give me plus 25. Divide by 5, and I solve for y. Y is equal to 5. Circle it. There's y. And if I take that y and plug it back into either one of these two equations, all right, I'll get an answer for x. So let's take it and put it back into the top equation. And that would give me 4 times x, 4x, and then plus 2 times 5. Well, that'd be 2 times 5 is 10, so plus 10 equals 9. Just finishing out the equation. Right. And then if I subtract the 10 from both sides, I would get 4x equals negative 1. If I divide by 4, I get x is negative 1/4. Well, if x is negative 1/4 and 5 is y, I would have negative 1/4, 5 for a solution. Now, I would check it. Since I put it into the top equation, I would plug it back into the bottom equation to check it out. Well, if you multiply, let me erase that little cancellation there. If I plugged negative 1 give me some yellow here. Right there, if I put negative 1 in there, negative 1/4 rather, this piece into there, I would get negative times a negative makes it positive, and 4 times 1/4 would be 1. So that would give me 1 plus 3, and if I put the 5 in there, 3 times 5 is 15, and 1 plus 15, does that equal 16? And yes, it does. So that checks, and that makes this a good answer. That, again, is elimination. Now, I'm going to go ahead and skip past this one here. We'll go down to this one and look at this system. And notice that I've got 2x plus 7y equals 4, 3x plus 5y equals negative 5. Equation 1 and equation 2, I don't have any opposites, and I don't have one piece that I can multiply by. But let's look at, say, eliminating. Let's go after the x's. I would multiply the top equation by a 3, which would give me 6x's. And if I multiplied the bottom by negative 2, that would give me negative 6. So let's go ahead and multiply that top equation by 3. That would give me 6x. I'll write it over here. Plus 7 times 3 would be 21y equals 4 times 3 is 12. Now go to the bottom. Whoops. Try that again. Go back down here. Go to the bottom, and I would multiply the bottom equation by what we said, negative 2. All right? So that would give me 3 times negative 2. That's going to be negative 6x. And 5 times negative 2 would be negative 10y. And negative 5 times negative 2 is positive 10. Okay, there's where the x's cancel. 6x and negative 6x. Just adding those guys together. Okay, 21 and negative 10 would give me a positive 11y. And 12 and 10 would give me 22. Now, if you divide both sides by 11, what's y? Yeah, it's going to be 2. Circle it. You got your y value. Now, you can go to any of these equations or these equations and plug the y in to solve for x. I'm going to go back up to the top equation. It's a little smaller. And I'll plug y in there. That would give me 2 times x plus 7 times 2, which would be 14, equals 4. Then I'll subtract the 14, both sides. They'll give me negative 10 on the right and 2x on the left. When I divide by 2, I'm going to get x is negative 5. So when y is 2, x is negative 5. So we would have a solution of negative 2, negative 5, 2. At least I wrote it right. I said it wrong. Negative 5, 2. My check would be to plug it into the second set of equations. 3x plus 5y equals negative 5. That's going to give me negative 15. Negative 5 in there. 2 inside of there would be plus 10. And that should equal negative 5, does it? Yeah, it does. That checks, and so this is a good solution. Now, what happens when you add these together? Let's look down at example number 5. When you add the two equations together, okay, I see I got a negative 3x and a positive 3x. If I add those together, they cancel. But notice when I add the y's together, they also cancel. And, in fact, when I added the 5 and the negative 5 together, they cancel. It left me a 0 on the left side, but it also left me with a 0 on the right side. Now, before you get panicked here, does 0 equal 0? Okay, so this is one of those situations where the variables dropped out, and I have to ask the questions, is it a true statement or not? And this would be true. So when it's true, that means that I have infinitely many solutions. So we put infinite many solutions. Okay, might be tempted to put all solutions, but we don't have all solutions. Only the ones that work in the first equation are going to work in the second one. So there are infinitely many. If you had to find one, stick a number in for x, solve for y in that first equation. That'll give you 1. That's if you had to find one. All right, what happens on the other side when I add those together? Here we've got on example problem 5, the 4x and the negative 4x cancel. Oh yeah, the 6y and the negative 6y also cancel. But I end up with 16 on the left. That leaves me, or on the right, I get 0 equals 16. That's not true. So here again, the variables did drop out, but it's a false statement. Okay? And when they're false, that means there is no solution. To take that one step further, that means in this system, those two equations are parallel lines. We're not asking for that, but that's exactly what the uniqueness of this means. When the two lines are not going to have a true statement, but there's no solution, then there are parallel lines in the system. Okay? That's how we did elimination. Okay, if there's any questions on that, feel free to contact me again.